In this lesson, we're going to look at frequency tables, and we're going to construct frequency tables for both ungrouped and grouped data. And after we're finished with frequency tables, we're going to go to the class features, and those would come from grouped data frequency table. Those class features are class intervals, class limits, class boundaries, class midpoint, and class width. So the first thing we're going to do is to define what is a frequency table, and then we're going to go into examples of constructing frequency tables with ungrouped data and group data. So the first thing we're going to look at is what is frequency table or frequency. So the frequency of an event or observation or score is defined as the number of times an event has occurred. A major way of organizing raw data into some sort of order is to arrange them in the form of a frequency distribution, and a tally chart is the best method of doing this. Now, when you're creating frequency tables, you would see that we would use a tally chart, and that is when we're given the raw data, we have to go through each individual number one by one, and then we're going to place them onto our frequency table. Now there is something called relative frequency, and at the bottom there you have the formula to find the relative frequency. So that is the frequency of the event divided by the total frequency. Now remember, frequency is the number of times an event has occurred. So if you're looking, let's say you have a distribution, you have a set of data, and you have a distribution, let's say you're looking at how you toss a die. So a die carry numbers from 1 to 6, and let's say you rolled 6 8 times out of 10 rolls. Let's say you got 6 8 times, so the frequency of getting a 6 would be 8, and the total frequency would be how many observations you have, or the frequency of all the other observations. So you're dividing the frequency of that event by the total frequency. We would be working this question, so pause the video and copy the question. So you would have copied the question, and let me just go through it. So there are 50 participants in a shooting competition. The score of each participant is listed below, and then they give you 50 numbers there. Now I don't have the space to write all 50 numbers and then put them onto the table, so I'm just going to go through the first three columns, just so that you get an idea of how you place these raw data into our frequency table. And if you notice, this is frequency table with ungrouped data, right? So how do we get our scores? So what you have to do is that you have to look at the numbers that you're given, and then you look for the smallest number, and then you look for the largest number, and then your score becomes or you write your score from the smallest to the largest. So you go 0 1 2 3 4 5 6 7, right? So those are the numbers we have in these 50 numbers that we're looking at. So what we do is we go through now. So you have 6 1 4 3 0. So everybody should know how to do tally. So tally is 1 2 3 4, and then you tie the bundle to make it 5. So you count in fives, right? Alright, so under the tally column, so we have 6 1 4 3 0. So we have 6 1 4 3 0. Let me put some lines across. So we're finished with this first one, right? So you cancel them out and you place them. As you go through, you place them into the correct row that it needs to go. So you have 3 1 5 0 4. So 3 1 5 0 4. Strike them out. Then 7 4 6 1 3. 7 4 6 1 3. Now at this point you're going So, and we strike these out because we're finished with them. You're going to pause the video here, and you're going to complete this table. That is, you're going to go through your 50 numbers and you're going to complete the table. Alright, so now that you have completed the table, well, I've completed mine. So let's write in our frequencies. So for 0, you had 1, 2, 3, 4, and the stroke means that this is 5. Here you have 5, 10, and 2, that's 7. Here you would have 3, 5 and 4, that's 9. 5 and 3, that's 8. This would be 4. This would be 5. And this would be 4. Now, when you sum your frequencies, you should get a total of 50 because there were 50 numbers that we were working with. So remember, with ungroup data, you take the raw data and then you go through them individually and then you place them into the correct rows, and then you write your frequencies at the end and then you sum your frequencies. We would be working this question, so pause the video and copy the question. So we're now looking at frequency table with group data, and you have the question there that you would have just copied. So the mass of 100 students corrected the nearest kilograms are as follows, and then you have 100 numbers there. And then the first part, or A part, says draw up a tally chart for the classes, and they give you the classes 35 to 39, 40 to 44, 45 to 49, 50 to 54, 55 to 59, 60 to 64, 65 to 69, 70 to 74, 75 to 79, and 80 to 84. Now, again, you're going to drop your table. Well, this side would be masses because we're dealing with the mass of students, and it's in kg. And then the classes that they gave you, you place them here, right, on the mass, and then you have the tally and the frequency. And it's the same principle as with ungroup data, where you have to go through your numbers and then place them into their respective areas. So I don't have space to put all 100 numbers. I'm just going to do the first 2 columns so that you get an idea again. So we have 35, 41, 47. So 35 would be here, 41, 47. Then we have 53, 64, 74. So I'm finished with these. 53, let me deepen these lines. 53, 64, 71. Finish with these. 84, 75, 63. 84, 75, and 63. 52. So you have to be very careful when you're placing your numbers, right? 44, 59, 52. 44, 59, 52. 63, 72, 81. 63, 72, 81. 54, 63, 65. 54, 63, 65, and then I have the last one here, which is 70. Now what you're going to do is you're going to pause the video here and you're going to complete your table. So pause the video and complete your table. So now that you would have completed the tally part, let's put in our frequencies. So we have 5, 10, and 2, that's going to be 12. 5 and 3, that's 8. 10, 5 and 2, that's 7. This is 5, 10, and 2, that's 12. 5, 10, 15. 5, 10, and 2, 12. 5 and 3, that's 8. 5 and 2, that's 7. And 5 and 4, that's 9. So when you sum this side, you would get a total of 100. Remember, your frequency, when you add it up, should sum up to the number of numbers that you have, or number of observations that you had, right? So that's how you do the frequency table with on-group data and group data. Remember, with on-group data, they don't give you any classes, or they don't give you the part for you to put. So you'd have to look for the smallest or the largest. If they gave you, then you just use those. But with group data, they usually give you the classes. So you put the classes there, and then you go through your raw data, and then you place them into the tally, and then you add up to get the frequency. This frequency table would be used to go through the class feature. So pause the video and copy the table. Alright, so we're now moving to class features, and you would have had to copy this frequency table. So this is the frequency table that we're going to use throughout our class features. So the first class feature we're going to look at is class interval, and a class interval is defined as a grouping of statistical data. Now, when you look at this, you have class here, right? So that means that 35 to 39 is the first, or let me just write 1st, is the first class interval. So each one of these groupings, or each one of these classes, is a class interval. So if I ask you for, let's say, the fifth class interval, and the fifth class interval, you have to check 1, 2, 3, 4, 5. Your fifth class interval is going to be 55 to 59. Let's say I asked you for the 8th class interval, then 1, 2, 3, 4, 5, 6, 7, 8. The 8th class interval would be 70 to 74. So each one of these groupings is what we call a class interval. So this is the simplest one, right? The second class feature we're going to look at is class limits. So class limits are the end values of a class interval. There is a lower limit and an upper limit in each class interval. So let's look at our first class interval, which is 35 to 39. So 35 and 39 are our limits, but 35 is my lower limit and 39 is my upper limit. So all these first numbers here are lower limits, and all the end numbers here are upper limits. So if they ask you for the lower limit of the 6th class, you first have to find the 6th class. So that's 1, 2, 3, 4, 5, 6. So the lower limit is going to be 60. And if they ask you for the upper limit of the 9th class, again 1, 2, 3, 4, 5, 6, 7, 8, 9, upper limit is going to be 7 to 9. So your limits are the endpoints of your interval, and you have a lower limit and you have an upper limit. The third class feature that we're going to look at is class boundaries, and in order to calculate the boundaries, the boundary between two classes equals to the upper class limit of the lower rank plus the lower class limit of the upper rank divided by 2. Let's just find the boundaries for the second class. So we want the boundaries for this class, right? So the formula states, so we're going to find the lower boundary first, right? So it's the upper limit of the lower rank class. So if we're working with this class, then our lower rank class becomes this one here, right? So the upper limit of our lower rank is 39. So this is going to be 39 plus the lower class limit of the upper rank class. So if this is our lower, then this becomes our upper, right? So the other class limit we're looking at would be 40. So it would be 39 plus 40 divided by 2, which is going to be 79. Divide by 2, and that's going to give me 39.5. So the lower boundary for my second class is going to be 39.5. So let's find the upper boundary. So to find the upper boundary, we're still working with this class, right? So it's the upper class limit of the lower rank. So this now becomes the lower rank, right? So if this is the lower rank, then our upper boundary is 44 the upper class limit plus the lower class limit of the upper rank now becomes 45, right? Because this one now becomes our upper rank. It's going to be 44 plus 45 divided by 2, and that's going to give me 89 divided by 2, and that's 44.5. So the upper boundary here is 44.5. And if you are to work the rest, you're going to find that our lower boundary and our upper boundary is just 0.5 less than what is here, and the upper boundary is 0.5 more than what is here. So the boundaries for this class becomes 44.5, and the upper one would be 49.5. For here is going to be 49.5, and for this is going to be 54.5. Here is 54.5, and this is 59.5, and so on. So when you're looking at the boundaries, it's always 0.5 less than our lower class limit and 0.5 more than our upper class limit. That's the easiest way to remember it. It's 0.5 less than our lower class limit and 0.5 more than our upper class limit. But if you want to work it out, you have the formula there, and that's how you work it. So it's the upper class limit of the lower rank plus the lower class limit of the upper rank. You add them and then you divide by 2, which is just like finding the average of the upper limit and the lower limit. And for this one, it would be 34.5 and 39.5. Remember, it's just 0.5 less than our lower class limit and 0.5 more than our upper class limit. The fourth class feature we're going to look at is class midpoint. And it says that the midpoint of a class interval can be used to represent the entire class. So instead of using the classes like 35, 39, you could just find the midpoint and then use that one number to represent the entire class. And there's a formula, and that is the lower class boundary plus the upper class boundary divided by 2. So we're going to find the midpoint of our second class, which is 4 to 44. So our lower class boundary, we found to be 39.5 plus our upper class boundary, which is 44.5, divided by 2. And when you add the 2, you're going to get 84 divided by 2. So the midpoint is going to be 42 kg. So somewhere in here, 42 is the midpoint of that class interval. And if you want, you can go and find the class interval, the midpoint of the other classes. So this would be 44.5 plus 49.5 divided by 2, 49.5 plus 54.5 divided by 2, 54.5 plus 59.5 divided by 2, and so forth. And that's how you find your class midpoint. And the last class feature we're going to look at is the class width, or sometimes we call it the class size. And to find the class width, the formula is the upper class boundary subtract the lower class boundary. So let's look at our first one. Our upper class boundary is 39.5 kg, subtract my lower class boundary, which is 34.5 kg, and that's going to give me 5 kg. And if you're to use any one of the classes and find the class width, you're going to find that it is 5 kg. So the class size or the class width is the same throughout all the classes. So to wrap up today's lesson on frequency tables and class features, remember that frequency is in the number of time an observation occur within a distribution. You will have frequency tables with ungrouped data, then you have frequency tables with grouped data. With ungrouped, remember you have to identify the smallest to the largest and then you list those, or if they give you, then you use them. You go through your set of raw data and then you place them into the relevant rows, and then you write the frequency at the end. With group data, remember that they gave you the classes. You use those classes and then you place your raw data. And for class features, remember you have 5 of them: the class interval, class limits, class boundaries, class midpoint, and class width. Class intervals is as it is every class. The limits would be endpoints of each interval. Your boundaries is 0.5 less than your lower class limit and 0.5 more than your upper class limits. You have the midpoint, which is the lower class boundary plus the upper class boundary divided by 2, and then you have the class size, which is your upper class boundary subtract your lower class boundary.